Okay, so the second integral that I have to evaluate is the integral from -2 to 1 of ln of x squared plus 4x plus 5 dx. Now, I don't know about you, but I hate seeing these bounds. So what I'm going to do, because this requires a lot of steps, is I'm going to pretend that these bounds don't exist for now, solve it as an unbounded equation, then go back and add the bounds. Because I don't want to keep like putting -2 and -1 here. So we're left with the integral of ln x squared plus 4x plus 5. And if you actually complete the square here, you get x squared plus 2 all squared plus 1. So that's the integral that we have to evaluate. Looking here, the best thing I can think of is just doing a substitution and seeing where it goes. So we can say y is equal to x plus 2. So then that makes dy is equal to dx. So now our integral becomes the integral of ln of y squared plus 1. And by doing, like, the only thing I can think of is because there's a ln here, right? And the only way you can solve it is through IBP. So we're going to set u is equal to ln of y squared plus 1, making du, oh, I kind of forgot to put the dy here, making du is equal to 2y over y squared plus 1 dy. There we go. Now, you just got to rearrange, solve. Actually, you don't even need to, yeah. So now what you got to do is you got to say dv is equal to dy, right? Because that's the only thing that's left. And that makes v is equal to y. Now you're going to plug that into this IBP equation. And that gives you y ln of y squared plus 1 minus the integral of y, 2y, over y squared plus 1 dy. Now I'm going to bring this 2y in, and we end up with this equation right here. So all that's changed is now we have 2y squared over y squared plus 1. I'm going to go to another sheet for this just because there wasn't enough room to do this all together. So, but basically, to solve this question, you have to integrate this now. So that's the integral of 2y squared over y squared plus 1 dy. And the only way I can figure out how to solve this is because we have a squared here and a squared down here. So we have to divide these two to just make it an easier integral for us. So what we would do is we would have y squared plus 1, and we would divide 2y squared by that. And we end up getting, if we multiply this by 2, we get 2y squared plus 2, and so we subtract the top and the bottom, and we're left by a -2. Therefore, our final, after dividing, we get 2 minus 2 over y squared plus 1. Okay, so that is our integral now, and you can easily integrate this because the integral is 2y, and then 2 over y squared plus 1, we can just take out the 2, and if we look here, it's just y squared plus 1 with a 1 on top if we just ignore the 2 and just bring it out here. So we're just left with 1. And you can see that this is actually just arctan of y. So now our final answer is 2y minus 2 arctan of y. But we're not quite done yet because we just got here, okay? Now we're going to put what we got here. So it's minus the integral of 2y squared over y squared plus 1. So it's going to be minus 2y plus 2 arctan of y. Now, we had bounds before in the beginning of this question, and I removed them, so I'm just going to put them back in. So what I'm doing now is I'm going to say that because we set y equal to x plus 2, at x is equal to -1, we get y is equal to 1. And then at x is equal to -2, we get y equal to 0. So our bounds are now 0 to 1, which I personally like much better than -2 to 1. So we're going to put those bounds in right there. And then just plug them in. So when you plug it in, you get 1 as y, so just 1. Ln of 1 squared, which is 1, plus 1, so that becomes ln of 2 here, minus 2 times 1, which is just 2, plus 2 arctan of y, and arctan of 1 is pi over 4, so you get 2 times pi over 4, minus 0 times anything is 0. So this whole thing becomes 0. Again, this whole thing becomes 0. Plus 2 arctan of 0. So arctan of 0 is also 0. So this whole part is 0. And your final answer becomes ln of 2 minus 2 plus pi over 2, which isn't that bad.